Hey, good morning, guys. Today we are going to discuss about the block level backup using Commvault. So we know that all the backup tools. I mean, most of the backup tools, generally when they work, they are working on the file level. I mean, the backup which is taken is actually the file level backup. So when we say file level backup, so that means when they are actually reading the file, I mean the data what need to be backed up, they are actually reading the individual files which need to be backed up. For example, if I talk about Commvault in scan phase, let's suppose if it's an incremental backup, then what will happen during the incremental backup? The Commvault agent will identify all the files which has been modified after the last backup. So all those files will be read. I mean, all the files will be noted down. Whatever the files has changed after the last backup, and those files will be backed up. So this is what we mean by the file level backup. Now, talking about the block level, what exactly the block level backup is and how it is different from the file level backup. So block level backup is actually ignore the file systems, okay, and it actually read the data from the storage blocks that we have on the disk level, right? We have the disk level, like any disk which has been configured as a C drive, D drive, or E drive in your computer. So let's suppose it's a D drive in the background. It's some dedicated hard disk which is coming up. It might be that hard disk is local, or it might be that the hard disk is coming up from some storage device. So that particular hard disk has the block, or I can call it as an extend in case the files are written on them. So what Commvault does when you enable the block level backup? So what Commvault does, instead of reading the files, individual files, okay, it backups the blocks. It backups the blocks. It read the blocks on the disk or on the hard disk, and it read the data at the block level. Okay, so in this way, the backup that this block level backup is actually very faster from your file level backup, because your file level, I mean, see, in case of file level backups, I mean, we prefer, let's suppose there's a large number of files which need to be backed up. So if we are going to scan all those files, it is going to take a lot of time. Okay, so in case if we are using a block level backup, so block level backup will not be reading the files no matter how many files you have. It will be reading all the blocks, all the disk blocks which is lying on which the data is actually lying. Okay. Okay, now this is a diagram in the background through which I have just tried to explain how exactly the block level work. Let's suppose this is a client for which we are trying to take the backup. On this particular client, we have C drive on which OS has been installed, and then we have the D drive on which the data is actually lying. Okay, so first thing that we need to remember is by default you cannot configure or you cannot enable the block level backup for the OS disk. Okay, by default it is disabled, but of course if you want to do it, you have to put some additional key setting, for which I'm going to provide the link in my video. Down in the video you can just go over there and you can just check that particular link where we have given the information about the additional setting key that we can put if you want to enable the block level backup for your OS drive. Okay, let's suppose it's a D drive on which the data is lying. In case of file level backup, if I talk about the file level backup over here, let's suppose in the D drive we have the XYZ folder, and in the D drive we have the ABC folder, and over there we have the .mmm, .pdf files, and a lot of files are lying over there. So in case of file level backup, the Commvault is going to read each and every individual files and directory to take the backup. Okay, it is going to scan each and every file which qualify for the backup. But what happened in case of the block level backup? Let's suppose this is a disk, okay, and it has multiple blocks lying over there. Okay, so Commvault will be reading all those blocks, okay, whatever the blocks, the data has changed, all that particular data will be backed up instead of files. Okay, so that process is a little faster. It's not little, but yeah, it's faster than your file level backup. Okay, now this file level backup, I mean this block level backup is, it's the main advantage of your block level will comes up when you have the large number of files on a single disk lying and you need to back up. For example, in the case of file server where you have a lot of files, which need to be backed up. So in that case, it will be very useful to use your block level, what I say, the block level backup instead of the file level backup. Okay, we'll just discuss more details about the block level backup, that how actually block level works in case of Commvault, and how actually it is. I mean, what are the backup phases, or what are the phases in that particular job when your this particular backup is running, when your block level backup is running. Okay, we are going to discuss later on that how to enable it, how to configure it, what are the things that we have to keep in mind, what are the prerequisites that we will see later in this video. But right now I will just tell you how exactly this particular backup works, how the block level backup works. Okay, so you can see the window down in the back of, I mean, right now on the screen, you can see the window. Okay, now let me tell you when block level backup job runs. Okay, this particular block level jobs has two phases. One is called snapshot copy phase, and the another one is called backup copy phase that we are going to discuss in the next slide. Okay, right now we are going to discuss about the snapshot copy subphases. Okay, like the first phase is snapshot copy phase, and this particular snapshot copy phase has the further subphases. So we are going to discuss the snapshot copy subphases first. Okay, so if we go further, then the first phase that actually lies in the backup subphase is the snapshot created. Okay, now for snapshot, for that particular volume, for whatever volume you have defined, I mean, you are trying to take the snapshot or a block level backup, for that particular volume a snapshot will be created. Okay, now if you're using a Commvault native engine, okay, if you're using a Commvault native engine for taking up the snapshot of that particular volume, that is mostly used in case if that particular volume is local. I mean, and that volume for which you're trying to take the block level backup is a local hard disk. Okay, and it is not coming up from some storage devices. So in that cases, most of the time we prefer to the Commvault native engine backups. Okay, that will be used to take this snapshot. And even if it's coming up from the SAN or the another storage devices, then also you can use this particular Commvault native engine backups. But in that case, you have the choice if you want to use the Commvault native engine backups or the hardware backup snapshot engine of that storage itself. So if I talk about the local hard disk, in case of local hard disk, you have only the option to use a Commvault native engine backups. Okay. Now that Commvault native engines actually uses the VSS, volume shadow copy services, VSS, to create the snapshot. Okay. We are going to install the VSS provider as well on that particular server that we are going to include in the prerequisites. Okay. Once I mean that snapshot has been created using the whatever the engine that you have done, so there is something called QSnap drivers of Commvault. Those drivers will monitor that particular device, and it will create something called bitmap. Okay, and what exactly this bitmap does? This bitmap actually keeps the tracks of the block, okay, of your disk. If that particular data on that, I mean, if the data on that particular block is going to change, then this particular bitmap is going to modify, and it will represent that this particular block has been modified, so that it will be easier for us when it's coming to the incremental backup to track down that which particular blocks need to be backed up. Because when we are not tracking down the files over there, files has the feature like it features like the last modified time. So using that particular feature, Commvault software can just identify that what are the files that has been modified after the last backup time. So but what is a way, to monitor the blocks? I mean, how we can monitor the blocks that when the data in those blocks has been modified. So that is actually tracked down using the bitmap file. So this bitmap file has been created by the QSnap driver. This bitmap file have a bit relevant to each and every block. So whenever there is a data which is written, I mean, there is a data which has been modified into some block, so that particular bitmap, I mean, the relevant bit will get modified, just indicating that the data in this particular block has been modified. Okay, in this way we are going to track down the what are the blocks that has been changed after the last backup. Now once that has been done, once this has been done, so what will happen, that after that there will be a something called config file that will be created for that particular device or drive.
for that particular drive, a config file will be created, and that config file contain the volume details and properties. Okay, that will contain the volume, details and properties. So these are the things that actually happen in case of your backups of phase of your snapshot phase. Okay, so what are the things that has happened in the first step? A snapshot has been created using the QSnap driver of Commvault. The bitmap file has been created to track down the block changes, and the config file has been created. Now the second step which is there in this one is scan surface. Okay, now if you want to have a file level recovery, okay, if you want to use the file level recovery option that we are going to discuss in detail while we are actually configuring, we are going to configure in the lab. But if you want to do it, I mean, if you want that, metadata should be collected of about the files which has been backed up, if you have enabled that particular option, then you will be like metadata collection will be happen for the whatever the data has been backed up, and the file, the config file and your qsnap file will be uploaded to the index in the next phase. If I talk about the index, okay, so we are simply referring to this particular diagram. Okay, so over here, when we have just started the backup, the block level backup, so bitmap has been created. This configuration file has been created for this particular D drive, and this bitmap file and the configuration file has been uploaded into your index. Okay, is already upload. I mean, will be uploaded to the index of your media agent and as well as for the ComSub. I mean, it's just a catalog. When we say index, so we are referring to the catalog over here. Now once that has been done, okay, all the in the next phase, the catalogs of phase, all the file level metadata that has been created in your scan phase will be collected and will be written to the index as well. Now the second last phase that we have in this snapshot phase will be the archive index of phase. The index, whatever the index that has been created during the catalogs of phase, that index will be written to your disk library as well. Okay, in this particular disk library as well, and it will remain in the disk library till the time that particular block level has the retention. Okay, and that retention we actually define in the storage policies. And the last phase is cleanup phase. Once all these step has been done, then whatever the snapshot that you have created will be deleted. Okay, or not sorry, not the snapshot will be deleted, but the temporary files related to your snapshot that has been created will be deleted from the job result directory. Okay, so this is about your snapshot phase that is actually there, the first phase which we are talking about as of now. Okay, the second phase that we have in the block level backup is called is called backup copy phase. Okay, so over here, as you can see in the background for the I mean the snapshot, this particular diagram, sorry. So you can see in the backup copy phase, we the first phase which is there, the scan phase. In this, the volume bitmaps and the block device config file that was created during the snapshot phase has been downloaded from the index. Okay, so that will be used, actually will be used to track down all the changes, I mean all the changes that has been done on the block. And once that has been, those in files has been downloaded, then the snapshots are mounted. Okay, and it has been mounted, it will be mounted on your client itself, or it will be mounted on your media agent. Okay, but you cannot, I mean, you can define it, but that is in case if you're using the hardware snapshot engine. If you're using the Commvault snapshot engine, then that you cannot define the proxy where this snapshot will be mounted. Then by default it will be mounted on the client for which the backup is running. So that snapshot will be mounted and the extents are moved from the snapshot to the media. Okay, that is media, we are talking about the disk library. That means that using those particular snapshot, the data from your actual drives will be moved to your disk library. Okay, once that has been done, the index for the backup job will be backed up to the media as well. Okay, now just a very important point that we have to keep in mind over there, that if we are using the Commvault engine, okay, Commvault snapshot engine that we have already seen in the last diagram, that if we are going to use the Commvault native engine for the backup, so in that case your snapshot copy phase and your backup phase both will be running under a single backup job. Okay, so it will be kind of a spool copy for the snapshot. Like as soon as snapshot has been created, using the snapshot, backup copy will be created in which the actual data will be written to your disk library. Okay, so as soon as your backup get complete and completely written to the disk library, then the relevant snapshot will be deleted automatically. But if you're using a hardware backup snapshot, that is I mean, if the drive is coming up from the NetApp or some other SAN device, and you are using that particular, I mean, their storage snapshot engines to create the block level backup. So in that case, snapshot phase and the backup copy phase will be running as a two individual backup jobs. Once snapshot has been created, then you have to run the backup job, okay, to make sure that actual data is getting copied to your disk library, to your, if I look at this particular diagram, then you have to run that. I mean, in case of hardware snapshot, you have to run the backup copy to make sure the data is written to disk library. But in case of Commvault snapshot your engine, if you're using the Commvault snapshot engine, then by default it will be a single job, and it will make sure, by default Commvault will make sure that as soon as snapshot has been taken, and the actual data will be written to disk library using this snapshot. The process in the both will remain same. It just for the hardware snapshot engine, two backup jobs will be running differently. But in case of your Commvault snapshot engine, a single backup job will run, which will include both of your phases. Okay, now we are going to discuss about the prerequisite or the things that we have to keep in mind. Okay, while configuring this block, I mean, before configuring the block level backup. Okay, the first important thing that you have to keep in mind is that you should have the enough space in your job result directory of your client. Okay, your space, depending the amount of space you required in the job result directory, will totally depend upon the volume for which you are trying to perform the restoration. If you're trying to perform the restoration of your entire volume, so you will require at least that much of size on your job result directory. Otherwise it might get failed. And even if you're trying to perform the individual file restoration, okay, if you're trying to perform the individual file restoration using your block level backup, so in that case you require the size at least equals to your the files which you are trying to perform the for which you are trying to perform the restoration. So always make sure that you have the required amount of space in your job result directory. For more further details that how much exact space you required for the job result directory, you can refer to the Commvault documentation, for which I'm going to put the uh, link over there, so you can see the link, and you can just click on those link down there, and you can just read about how much exact space you required for the job result directory. Okay, now to get the details of the supported OS, file system, drives, and the sector size of your hard disk, to get all that information for your Windows as well as for your Unix machines, I have just put down a matrix support matrix link, which you can just open, and you can see what are the OS which has been supported by the block level backup. Okay, now if I talk about the Commvault license, so there is no specific Commvault license that has been required to configure the block level backup. There is no extra licensing charge that is required. The only extra occupancy that it will require is it will require the media agent license, one media agent license, and that should not be a concern if you're using a capacity based license, which most of the time we does. Okay, now the next most requirement which is there, which should be there to configure the block level backup, is that on this particular client for which you are trying to configure the block level backup, on this client you have to install the file system agent, plus the media agent should also be installed on this one. Always remember, media agent should be installed on that particular client for which you are trying to take for which you are trying to configure the block level backup. This is the must condition that you have to keep in mind. Remember, I'm just repeating it again. You have to make sure that on that particular client for which you are trying to perform the block level backup, you should have media agent software installed on that particular client. Okay, now the one more next important point or the prerequisite or that thing you have to keep in mind, that if there is a client that you have upgraded from the version 9 or version 9 to version 11, okay, so in that case by default you will not be getting option to enable your block level backup. Okay, you have to perform the manual operation. Okay, I can send you the, I mean, the process to enable the block level backup for those client will be little different. For that one also, I'm going to put the link, okay, for the Commvault documentation that you can follow, which is provided by the Commvault. Commvault, they will be using that particular link. I mean, they have defined the process, so you can use that particular link, and you can just go and check that how you can enable the block level backup for the clients which has been upgraded from the V9 or V10 to V11. Okay, so these are the requirements, or I can say prerequisite. These are the four prerequisite that you have to keep in mind. Okay, always remember, you can note it down them, or you can just remember the 4 or 5 points that I have told you. Okay, once you have met the prerequisite requirements, all the prerequisite requirements, then you can simply go to the lab. I mean, you can go to your client and you can enable the block level backups. So we'll see how to enable the block level backups in the lab. So we will log into our ComServe. Okay, this is the machine over here for which we will try to configure the on which we'll try to configure the backup. Okay, we'll just log into our ComServe machine, and let me put the username and password. Okay, so this is my console over here as of now. Okay, and right now there is no job running for me, so I will go to the client computers over here. And once I go to the client computers, let's suppose this is a client for which I'm trying to configure the block level backup. So on this particular server, I have taken this particular server because on this particular server the media agent software is also installed. So to verify that, if I go to the storage resources, expand the media agent tab over here, under the media agent I can see the server is shown. So that's mean on this particular server I have installed the media agent. So my first requirement is already met. Okay, I have I mean, I'm using the capacity based license, so I have n number of media agent that I can configure over there. Okay, now file system agent is already deployed, so I will go to the file system. Okay, and I will go to the default backup set over there, and let's suppose I'm going to create a new client sub client over there, on which I'm going to configure the block level backup. So I will right click on the default backup set. I will go all task and will click on new sub client. Okay, and once you have clicked on the new sub client, the window will come up. In this window we will just define the name of that particular sub client that we are going to put as a test, and we are going to put as a block level backup. Okay, this is a name that I'm going to provide to this particular one. Okay, now the second option is content. Okay, in this content I have to define the content that I want to back up. Okay, now always remember, while defining the content, you are not going to define the subfolders. Okay, there is no, I mean, there will be no advantage if you are trying to define the subfolders to for which you are trying to take the block level backup. You have to define the entire mount point, or you have to define the entire volume. Okay, it is not recommended to define the individual file and folders to configure the block level backup. So that's comes to the we come to the conclusion that block level backup should be configured for the entire volume level. The reason being is that whenever you configure the block level backup and the snapshot has been created, the snapshot is actually getting created for the entire volume, no matter what you have selected in the subclient content, no matter what you have defined over there. So if you have defined a single folder in that particular drive, then also the snapshot will be taken for the entire volume. Okay, so it's always recommended to define the content on the I mean, for the at the volume level or at the mount points. Okay, let's suppose you have the nested mount points. For example, for in this server, if I talk about in this particular server, in the C drive I have the mounted mount points, like in the further disk library I have the configured two mount point as the mnt01 or mnt02. Either I can define the entire mount point over there. Okay, so or if I define the entire C volume over here, then also your mount point will be covered over there. Okay, so make sure this thing always remember. Now coming to the backup system state, we cannot select the option backup system state over here because system state backup is not supported for your block level backup. So I have already told you that by default os drive block level backup is disabled. So if you have to enable the os level backup, OS drive block level backup, then you have to put some additional key for which I have already provided the link. So you can just refer to that particular link and put the additional setting, and then you can configure the block level backup for that one. So right now on this one, I'm just going to select any normal drive from this particular server that might be. I can select the entire H volume over there, click on add and click on close. So I can see the entire H drive has been added over there. Okay, now coming to the filters. Now on this filters, you have to remember this point that filters will not work for your block level backup. Block level backup will not consider the filters. If you have put any folder over there or any files in the filters, then those files or folders will not be excluded from the backup, because the reason is again the same, that because this snapshot is taken for the entire volume level, this snapshot is not taken for the individual folders. So snapshot will be taken for the entire volume. So no matter what you are defining in the filters, so it will be again covered up again. I mean, it will be covered up under the your block level backups. So there is no advantage of keeping the filters. So filters will not work, will not be relevant in case of your block level backup. Okay, you might see like you have configured the block level backup and you have defined the filters, but still you will be able to see those files and folders while performing the browse operation or restore operation. Okay, do not get shocked, because that will be, I mean, do not because that will be there. I mean, it will be by default there. Okay, once you have defined the content, you have defined the filters, you know what is the requirement for them, then you will go to the advanced option. Okay, in the advanced option there is a second last option with the name advanced options again. Okay, click on advanced option and there is a first option that is coming up, block level options, block level backup options. Okay, if you want to enable a block level backup for this particular subclient, just enable this particular option, that is optimize for file system with large number of small files. That is your block level backup. Okay, now remember a very important point over here. By default your block level backup will not support granular level recovery. Okay, it is not creating the index. Okay, it does not create index by default. Okay, and this is what is recommended for the block level backup. If you want to create the index for the data which you are trying to take the backup, then you have to select the option create file level index during backup. Okay, but if you select this particular option, okay, if you select this particular option create file level indexing during backup, then it will take a lot of time to create the index. Okay, the scanning time will increase to a very large extent. Okay, and it is not recommended in case of block level backup. Okay, because it will hamper your backup performance. Okay, backup performance will be degraded while performing if you select the option create file level index during backup. Okay, now option now there should be a question that should be coming in your mind, that if this option is not by default enabled and it is not even recommended, then whether it is possible to perform the granular level recovery or not in case of block level backup. The answer for this one is yes, you can still perform the granular level recovery, and that can be done using the feature live browse. Okay, live browse is a feature which is by default there. Okay, which is by default there whenever you if you have not selected this particular option create file level index during backup, and you try to perform the granular level recovery for that particular server, then the live browse will happen. I mean, those data which you have backed up will be mounted somewhere. It will be mounted on your media agent or on the client. Okay, and wherever it has been mounted, after it has been mounted, after that, I mean, then you can read that particular data in those particular drives. Okay, but by default you remember the file level I mean file level granular level recovery is not supported. I mean, I will not say not supported, it's not enabled. But if you still want to have granular level recovery or the indexing you want that index should be created during the backup for all the files which has been backed up, then you can select this option create file level index during the backup. Okay, right now I'm not selecting this particular option because again it will not give me any advantage over there. Okay, I will just click on over here and click on OK. Okay, and okay, now by default if you're not selecting anything, the engine that will be used, I mean, I told you while configuring that by default the Commvault engine will be used for backup, for the block level backup. So by default is a Commvault engine, but if you want to change it, okay, if you want to change it to any hardware snap one, okay, then you are going to select the IntelliSnap over here, and you are going to select the hardware snapshot engine that for that you are going to use. Okay, remember this point. If you remember, if you remember in this one, in this diagram I told you that if you're going to use the hardware snapshot engine, okay, that is coming up from the NetApp or IBM SAN or EMC, whatever that is supported by Commvault. If you want to use that particular engine for the snapshot, so in that case you have to enable this particular option of IntelliSnap, and you have to select the relevant engine over there. For example, if I select it over here, and if I have that particular engine, let's suppose that learn is coming up from the NetApp or from the HP3 power, then you can select it from there, HP3 power clone, or it's HP3 power snap, whatever it is. If I go to the NetApp, then you can see the NetApp is also very much there. So these are the all snapshot engine that is supported by Commvault. But as of now, I'm not going to select this one, because that drive that I have selected, that is H drive in the content, that is a local drive. So I will just disable this particular option of IntelliSnap, and will just keep this option of block level backup option. Okay, and even I'm not using the create file index level during the backup. This option is also I'm not using. Okay, so hopefully is it. Sorry guys, that was my phone ringing in between, so sorry for that. So yeah, we were discussing, like we have defined it, and we have just selected the option optimize for the file system. We have enabled this one over there. We'll just click on OK, and we have the content in place, we have the filter in place. Okay, we'll can enable the and, but we have not applied the storage policy, so we'll select any relevant storage policy that we have. So we'll click on OK, and our subclient will be ready to take these snapshot backups, I mean for the block level backups. Okay, so I mean this is how you are going to configure these snapshot backups, okay, that block level backups. Okay, so this is all about the configuration. Now that subclient will be coming up, it will take some time in my lab. It is there, it is asking me to associate with schedules. I will say cancel. Okay, it is already there. We'll try to run a backup for this one. Okay, but before we move to that, I will discuss the performance factors. I mean, what is I mean, how much performance improvement is there when we are configuring the block level backup? So that thing I'm going to show you in this one. Okay, okay, so this is a diagram in which I'm going to show you that how much performance improvement that you will get if you're using the block level backup. Okay, so if I talk about the backup type, let's suppose this is a full backup I'm running, and in case of block level backup, let's suppose the number of files that I'm trying to backup is equals to something. This number is very huge. Okay, these are the number of files which I'm trying to backup. Okay, and this is the size of the total application. Okay, or I can say the size of the drive is at least amount of total of data, the total amount of data which is lying on that particular drive. If I'm doing this particular thing using the block level backup, so you can see the scan time which has been reduced to 23 seconds. Okay, and the scan time in the traditional backup, the normal backup which we are running, will be around 6 minutes or something. Okay, that's the reason being that in case of traditional full backup, it is going to scan all the files. Okay, it is going to scan all the files and see that what are the files that has been modified. Okay, and it will take, that's why it will take time. But in case of block level backup, the bitmap file will already contain the data. I mean, what are the blocks that has been modified after the last backup? So Commvault will just look at that particular bitmap. I mean, it will select all the blocks which has been modified for the backups. Okay, so that's why the scan time is very much reduced in case of your block level backup. Now, if I talk about the normal backup timing, okay, so when the block, I mean, Commvault is picking up the data at the block level. Okay, in that case, the time which has been taken to back up this amount of data, okay, or I can say this number of files is equals to 13 hours 39 minutes. Okay, and the throughput, even you can see the throughput which we are getting is around 80 GB per hour. Okay, and in case of traditional full backup, you can see the same backup timing. I mean, the backup timing for same amount of data is around 22 hours, because the throughput which you are getting is very small. Okay, and the application size and the number of files remain same. So you can just look at the backup timing difference, and you can just imagine what is the difference between them. Okay, it is almost the half, almost the half. Okay, so you can just analyze, and you can say that the backup performance in case of your block level backup is very high. Okay, this is about your comparison for your backups. Okay, now we'll see how the restoration will be. Okay, so this is a chart which you can see. Okay, and which you can see on the screen right now. Okay, and you can see over there that the amount of data that we are trying to back up, sorry, to restore is 1.1 terabyte. if I say if I am going to perform the restoration for the entire volume that has been backed up using the block level backup, so the restoration time is almost equals to the backup time that was shown over there in the last slide. But if I say the file level restore from the full block level backup, I mean, let's suppose if I'm trying to perform the individual files restoration, okay, for the block level files, I mean, from the block level job for which we have not enabled the indexing, okay. So in that case, you can see that if you are going to perform the restoration for all the files individually, then it will take around 39 hours. If I talk about the file level restoration from the full traditional backup, okay, it is equals to 46 hours, and that will be also equals to if you are trying to perform the restoration for the entire volume using your traditional backup, that will also take the 46 hours. So you can see the difference between 46 hours and the 13 hours. So this is a huge difference between your backup and your restore. The restoration time for the entire volume using the block level backup and using the traditional level backups. So the time, even, I mean, you can see that the restoration time is almost one third of your restoration time compared to the normal backups. And even your the normal backup time, the time taken to complete the backup for the entire volume is almost half. So even the backup as well as the restoration, both things are happening faster in case of your block level backup. Okay, so this is about your block level backup. Okay, this is all about your block level backup. Okay. Okay, so guys, we are again back to the Commvault console. Okay, and we'll try to take the backup of this particular subclient. So you can note it down over here. I have already changed the storage policy. There was some problem in that particular storage policy. So I've used a new storage policy and applied over there. I will right click over there on this one and click on backup. You can select any type of backup that you want to run. Okay, you can select full, incremental, synthetic, full, whatever you want. Let's suppose I want to run a full backup. I will click on OK. So as soon as you click on OK, go to the job controller. In the job controller, you should able to snap backup job that should be running over there, over here. So this is a snap backup job. It is actually a block level backup job which is going to run. Okay, and this is a block level job that is that got started. Okay, and we will wait for this particular job to get finished, and then we will try to perform the restoration for the individual as well as for the entire volume. Okay, guys, so the backup job that we started actually got completed, the snap backup that we started. So if we double click on this particular job, we can see that, amount of data that has been transferred to the network was around 12.28. Let's suppose the size of application is around 14 GB. Okay, and the time it has taken to back up the 14 GB is around 9 minutes. Okay, so this is about your block level backup. You can say no file level index has been enabled, that we have already seen at the subclient level. We did not enable it this one. Okay, and if I go to the events, in events you can see that it will show you that the snap has been created for the volume and the backup job got completed. So this backup job has completed both the phases, snapshot as well as the backup copy phase. Okay, and if I go to the attempts, in the attempts you can see all the phases for both the you can see all the sub phases for both phases, like for the snapshot as well as for the backup copy phase. Okay, it has the backup is there, scan is there, cleanup is there, archive index is there, then catalog, scan, and backup. So all those are things that we have actually discussed, right? We will while discussing that phases. Okay, and if I talk about the average throughput that we have got is around 107.13 GB per hour. Okay.
Okay, so since the backup has got completed, so we will just try to perform the restoration. We will right click on this one and we will see the backup history. Okay, and we will just look for that specific backup job. Okay, and this is a snap backup job that we can see that actually got completed. Okay, that is the block level backup. So I will right click on this one and we'll say browse and restore. Okay, and we'll say view content. Okay, right now it is going to show us the content over there. Okay, and if I if I double click on this one H drive, now you can see
what it says in the end. Okay, it says please note that this is a live browse operation. Live browse operation can take some time before the result appear in the browse window. Okay, since we have not enabled the file level indexing, okay, so that's why it is showing us. It has just now it has just mounted initially. I mean, it has hardly taken 2 3 seconds for us, but it might take, depending upon the size of your volume, it might take time to browse it. So still, since I have not enabled the live I mean the indexing, then also I can browse all the files which are there inside these particular one in these particular folders. Everything I can see. Okay, so that's how it is working. So live browse is the thing that is used in the background to perform, to provide you the granular level recovery. Okay, and if you want to perform the restoration for the entire volume, so what I can do is I will right click on this particular subclient and will say browse and restore. Okay, and over here in this window it will show you the option file level browse, or you want to perform a volume level browse. If I select the volume level browse, view content, okay, so I should able to see that particular volume, entire volume. I cannot do the individual ones. Okay, I will not able to say the content. I have to perform the restoration for the entire volume in that case. Okay, so these are the options which are available to you. Okay, remember this is how your block level backup and restoration will work. We have discussed all the prerequisites and all the things, and the support metrics link has already been given there. Now in this window you can just select this those one, and we are good to go. Thank you so much.